Okay, so now we will let's discuss about the chapter 11 of the challenge problem. So let's see. So we have the three radius of the 12 circles. Okay, then each of them is passing the center of the other two, right? So let's say the center is ABC. So this one, the circle B is passing the center of A and C, right? The circle A and the circle C. So let's just draw one of them. Okay. So because the center B is passing the A and C, and they all have the radius of the 12, so we constructed a equilateral triangle here. Then we want to find a common area of the shaded, right? So you can see this is the equilateral triangle, and we have a that's notating these three shaded the what's that? It's the lunar. Oh yeah, that is the lunar. Okay. Yeah, we find each lunar is 1, so this is the 1. So once we solve the 1, and so 3 times the 1 of the area plus the area of the triangle ABC, then it's the total shaded area. Let's solve the 1. So the 1 is equals to the 1/6 of the circle is pi times 12 square, then minus the equilateral triangle, right, is root 3 and 12 square. So now let's solve the 3 times 1 minus the ABC, plus the ABC, then it is the 3 times this one is half of the pi times 12 square, and minus 4, 3 to the 3 root 3, then 12 square, then plus the 3 of the 12 square. Okay, so if you take out the 12 square, then we have the pi over 2, then minus the root 3 over 2. Okay, so this is the answer. Next, so my cars will with a diameter of the 24-inch. So now let's see. Okay, so we have the originally is the radius, right? Is the radius R is 24-inch, right? So its speed meter reports with the correct. I recently replaced my 24-inch with a 28-inch, right? And I didn't change my speed meter. So the speed meter is like is doing this. Okay, it's counting the spinning of the cycles. So the number of cycles, okay, times the circumference, the 2 pi r, okay, then gets to the then accumulator get to the miles to travel. Okay, so now you can see so however, when the speedometer tells my car is going to 40 miles per hour, right? And now I'm using the 28 inches wheel, how far is my car really going? Okay, so you can see let's see, I mean, when we measure the 40 miles per hour, right? So we are doing the x cycles per hour. Okay, this is the cycles per hour. So what we do is the x cycles times the 2 pi times the 24, right? And this is in inches, right? Then we need to times the alpha. So the alpha is number of miles per inch. Okay, so we then we can change to mile. So this is the 40. We know this is the 40, right? So the question is y equals, it's the same number of cycles, right? Now we actually have circumference use the radius of 28 times the alpha is equals to what, right? So we want to solve the y. So now we have, this is the 1 and this is the 2. We can see y over 40 is 28 over the 24. So now we know the y equals 40 times the 7 over 6. Okay, then it is the 3 and the 210 of the miles per hour. Of 140. Okay, so next, so we have the two congruent circular coins, A and Z are touching each other. Okay, so we have a circle of the Z and we have a circle of the A, right? This is the touching point is P. So these two circles are congruent. So let's assume this is the 1, this is the 1, right? This doesn't matter. So when A is held stationary and Z is rotating around the A, right? So we want to find, so let's see, this is the P and this is the Q. Okay, so after rotating the half circle, right? So you can see the Q will be here, right? The Q will touch it. The Q will be here, okay? And the P will goes to here. The P will goes to this point, right? This is the P prime. So you can see after this moving, right? Because I mean the whole circle is moving to this here, right? That's from, if we don't move, if we didn't see, we touch this point. So you can see the point of the P from the bottom, right, is travel to the top. So means it's the P is travel. P travels half circle, half cycle. Okay, when the coin A, when Z travels a quarter cycle, right? So that means because the Z need to travel one cycle, right? Finally, need to travel one cycle. Okay, then that means the P need to travel 2 cycles, right? So this one, the answer is 2. Next, so the number of the centimeter in the perimeter of a semicircle is the same as the number of the square centimeter of its area. Okay, so now let's draw it. So what is the radius of the semicircle? Let's say the radius is x. So now the perimeter will be the 2 pi x. I mean the x 2x plus the arc, right? This arc is half of the circle, right? So the circle will be 2 pi times x divided by 2. Okay, so you can see it's 2x plus the pi x. This is the perimeter. Now let's see the area. The area is pi times the x squared, then divided by 2. So we have the 2 plus pi times x, they are equal. So now you can solve the x is equal to the 4 plus the 2 pi, right? Divided by pi. Next. So the cross section of a river is a trapsoid. So you can see when the river bank is like a trapsoid like this, and we have the base is the 10 and the 16 and size of the 5 and the 5. Okay, so the flow is the pi miles per hour. Okay, and a little is downstream in the dam. There are waters flow through the 4 identical circular holes. So we have the 4 identical circular holes, 1, 2, 3, 4. Okay, let's see, each has the radius of r. So we have the area is pi r squared times 4. Okay, so now you can see, okay, since the it's the flow, right? So that means the 1 hour, okay, it means like this. So this is the okay. So this is the volume inside. Okay, the 1 hour, the volume inside the bank is also goes through these 4 holes, right? So the volume of this one is equal to the area of the cut, right? So the S is equal to, let's see what is S here. The S is let's do the length to height. So this is the 10, and this is isosceles trapsoid. So this is the 3, this is the 3, this is the 3, 4, 5 triangle. Then the S is equal to half of the 10 plus 6 times 4. Then it's 2 times the 16 is 32. So the S of this, the bank is 32. So 32 times the pi mile per hour, then will be equal to the volume, right? So the volume is also equal to the 4 of this. This is 16 mile per hour. So it's 16 times the pi r squared times 4. Now you can, through this, we can solve the r square. So the r square is equal to the 32 over the oh, okay, I make a mistake here. It's 16, so it's the it is the 52. Okay, so it is the 52. So 52 equals this, then this one will be equals 52 over the 64. So divide by 6 is divided by 4 is 13 over the 16. So that's why the r equals the root 3 over 4. Next. So given the ABD in the diagram, okay, so this is the circle, okay? The circle, if this is the 90 degrees, means the AD must be the diameter, and the B is on the circle. So we have a right triangle. So then we have the BD equals 8, and this is the 8, 3. So we know if we find that this one is ratio is 1 to square root of 3, right? So we know this is the 30 degree, this is the 60 degree, then this one is 16. So now we want to find this area, right? The shaded area. So the shaded area is equal to half of the circle, okay, minus the minus this this triangle, right? So that's why we can see it's pi times 8 square divided by 2 is half of the circle minus half of the 8 times 8 root 3. Then what we have is the 32 pi minus 32 root 3. So a circle of the radius 3 pass through the center of the square, okay? So we have a square that is the with the side length of the 2, but it passing the center, so means this is the 1, and we have a circle of the radius of 3. This is the 1 and the 1, so 1 the circle that is like this. Okay, so it's asking us to calculate for the difference between the area of the non-overlapping portion. So the overlapping portion is this, right? Let's see, this area is x. So the non-overlapping portion, the 1 is equal to the pi times the 3 square minus x, right? And for the second part of this part, right, is equal to the 2 square minus x. So that's why the difference between the two non-overlapping is 1 minus 2 is equal to 9 pi minus x minus the 4 minus x. So it's 9 pi minus 4. Okay, so the second question, if we really asking you to how to calculate the part of the x, okay, what's the area of the x? So we can do this. We can connect it with the center of this circle, connected with these cutting points. Okay, so we can have this is 3, the radius, right? So this is the 1. Let me use another color to this is extension thinking, okay? Then you can see we can do this. So this is the center, so this is the this is the midpoint, this is the 1, this is the 1. So by Pythagorean we can solve this is 2 root 2, and we can solve this area called the P. So you can see is the P is the sector, and subtract the equilateral triangle area. Okay, I'm sorry, it's isosceles triangle area. Yeah. Next. So this is the bisymmetry. So you can see we have a quadrilateral. I mean, we have a regular hexagon of the A, B, C, D, E, F. Okay, then we do the circle like this. We draw the circle like this, circle like this, and when we draw a circle, yeah, like here, and the circle like this, circle, circle. Okay, so then we have this shape, right? So you can see here, let me cut it a little bit. Okay, so by symmetry, you can see after we cut, right? So we have an equilateral triangle here. So the area is the given AF is 6 and 6 and 6, right? So you can see in order to calculating the white area, we can cut into each piece is 1, right? So now we have the 12 piece of the 1. So now we can use the regular hexagon minus 12 piece of 1, then it's equal to the shaded, right? We can calculate piece by piece, right? So the regular hexagon is easy. It's 6 times the root 3 over 4 times 6 square. So this is the 6 equilateral triangles. And the one piece of the 1 is also easy, right? So it's the sector, 1/6 of the sector minus the equilateral triangle. So the 1/6 of the sector is pi times 6 square minus the root 3 over 4 times 6 square. Okay, so now we can see we can use the hexagon minus the 12 piece of the 1, right? So if you can keep simplified it, and finally the answer will be the 36 over 9 of the root 3 over 2, then minus the 2 pi. Uh, 34. So the number of the inches in perimeter of an equilateral triangle. So the perimeter of the equilateral triangle is equal to the number of the square inches in the area of its circumscribed. Okay, so this is the circumscribed the radius. Okay, this are the intersect of the 3 perpendicular bisector, because this is the equilateral triangle. So we know the perpendicular bisector here is also the angle bisector, also the median. So and the other thing is, this is also the center is also the centroid. So the ratio of this one is 2t and this one is t. So now you can see, if we see the the side length is a, right? So the r will be the 2/3 of the root 3 over 2a, so it's equal to a over root 3. Okay, now we can calculate the area of the circumcircle. So the area of the circle ABC will be the pi times the a squared over 3, and is equal to the perimeter, right? So the perimeter is 3a, so they are equal. Then you can see it is the pi over 3a squared is equal to 3a. Then we know that a equals 9 over pi. Now if a over equals 9 over pi, so the radius, it will be a over root 3, so it's the 3 root 3 over pi. Next, so the circle has 2 parallel chord of length. So here is the circle. Okay, if the circle has 2 parallel chord, that means the chord must be the equal distance to this circle. Okay, and that means these 2 chords inscribe a rectangle. So let's see, the chord length is x, so half of this is 2x, right? From the center to the midpoint. Then you can see this is the distance between the 2 chords is also x, so half of this is x over 2. So now we know that this is the isosceles right triangle. So this is the 45 degrees and this is the 45 degrees. Once we know the two 45 degrees, right, this is 45. By symmetry we know this is 90 degrees, so we know this part. Okay, so the area of the midpoint will be this one. Okay, that's a quarter circle, right? This is another quarter circle, right? So we have a half circle plus the two triangles. Now we can calculating what is that. So the half circle is pi, this is x over root 2, so pi times x root 2 square, this half of the circle, right? Then plus the two triangles, this 2 times 1 over 2x times the x over 2. Then this one is equals to the 2 plus the pi. Then let's simplify this side. So that means the x squared, then pi over 4 plus the x squared, right? Then 1 over 2 is equal to the 2 plus pi. So x squared of the 4, then it's the pi plus 2 is equal to the pi plus 2. So that's why the x equals 2. Next, so we want to calculate the area of the shaded, right? So it is the shape is the square, and we take the ABCD, and we take each point at the center. Then we try to draw the arc. So there is a lot of symmetry in this in this picture, right? The symmetry is if you draw the line, yeah, you can see the symmetry, right? So per symmetry, you what you can see is this point is passing the perpendicular bisector of the CD and AB. This point and this point passing the perpendicular bisector of the AD and the BC. Okay, so you can see the shaded area is constructed by this 4 little arc. This 4 little arc, and by cutting this arc, we can see in the middle we have a square. Okay, so once we solve the square and we solve each of the piece of the 1, so now we know the area is equal to this square plus the 4 of the 1. Okay, now we can see it, do it. So let's see we can this is the half, is a half, right? So now let's see of the how we can solve the piece of the 1. Okay, so to solve the piece of the 1, let me use another color. Okay, so let's connect it the B and this one and B and this one. So we have a sector in the green, right? And then we can cutting out this isosceles triangles to solve the piece of the 1, right? So now you can see, okay, so the first one is, let's land this one here. Okay, so you know this part, let me see. Okay, so you know the AB is 12, right? So this each side is 12. So you know half of this is 6, and this one, because this is the radius, right? This one equals AB, so this is the 12, and this is also equal to the 12. Okay, and then if this is the 6, this is the 12, right? So you can see the right triangle, that's using the E and F. Okay, you can see, and the G, you can see I have a right triangle of the E, G, B with 12 and 6. So you know this is the 30 degrees and this is the 60 degrees. So you know this is the 30 degrees and you know this is the 30 degrees. So here is the trisection, right? So you know this is 30 degrees. Now, if we know the 30 degrees, we can calculate in the sector, okay? So the sector will be pi times the 12 square, and 30 over the 360 is 1/12 of the sectors. So now we can calculate in the sector, right? We're calculating this one, and now we can also calculate in the isosceles triangles. Okay, this is the half of the 12 square and 1/2. Okay, so equals to the 3 times 12 equals 36. Okay, so this equals 12 pi. Okay, now we can solve the 1, right? From here, you can know the piece of the 1 is equal to the 12 pi minus 36 is equal to 12 the pi minus 3. Okay, now we solve the 1. After we solve the 1, we want to solve the length of this one, right? The length of each one. So if you know the trick, you can solve it easily, right? But if you don't know the trick, maybe you can solve the two diagonals. Okay, these diagonals can also, because it's a square, right, can also help you to calculating the area. So we already solved this one is 6, so we know this one is 6 root 3. Then we know this one is 12 minus 6 root 3, right? So you know this length is 12 minus 6 root 3. You know this length is also 12 minus 6 root 3. Then you can calculate in the middle one, right? So you can use the 12 minus this 2, right? So I can use the 12 minus the 2 times the 12 minus 6 root 3 is equal to 12 root 3, then minus 12 is 12 root 3 minus 1, right? So if you know the diagonal, then the area of the middle square is half of the 12 square, then root 3 minus 1 square. Okay, so this one is equal to the 12 square of the 2 minus the negative the root 3. So if you know this, right, so basically the shaded area, like what we show, is the square, right, plus the 4 of the 1. Okay, so now I leave the calculation for you. So the final answer will be the 144 minus 144 root 3 plus 48 pi. Okay, then this will be the final question for this chapter. So we have a quarter circle. Okay, we have quarter circle is B, D, O. Then we have A on the and X and B. So the question tells you the BAX. So this area is half of the quarter circle. Okay, so means the other two add together is also half of the quarter circle. So now let's see what is the radius is 1. So let's see, this is the x. We try to solve this x. So this is the 1 minus x. Okay. So now you can see, in order to solve the area of the OBX, this is the triangle, right? It's half of the x times 1. So is x over 2. Then we can solve the other thing is how to solve the XAD arc, right? So this one will be the we can solve the OAD with the arc minus the triangle OXA, right? Okay, so we know the AOD is 30 degrees, right? So this is the one, so we know the height is half. Then we can see the OAD arc will be the it's the 1/12 of the circle is pi times 1. Okay, then let's solve the OXA is 1/2 of the x times 1/2 is x over 4, right? So now we can solve the XAD is equal to pi over 12 minus x over 4. Okay, so finally we solve two p's, right? We solve the XAD and OBX. So we know the OBX plus the XAD then is equal to half of the area, right? The half of the quarter circle. So half of the pi times 1 divided by 4. Okay, now let's add them together. Will be the pi over 12 plus the x over 4 is equal to the pi over 8. Then we can, after solutions, we can see x equals to pi over 6. Okay, so that's it for this chapter. Thank you.